Hariharan, are you able to hear me?
Sir,
Yeah. So till now, what are the topics that we have completed? Can you just brief up? So it has been a week break, right? Let's try to have a small glimpse of it for the first 5 minutes. Let's recollect. And then we'll go to the next part. Okay. So just to recollect the concept, why are we studying this chapter? I told you in the first class. What is it? Is it only for accuracy and precision? Accuracy and precision comes for what? So the name itself suggesting, right? Units and measurement is actually the name of the chapter. So whatever measurement you take, you need a specific unit to be associated with it, right? I told you the importance of all those things. Similarly, when you do any measurement, when you take any measurement, what is unavoidable? Error. So you cannot say something is 100% efficient. It cannot work. Right? That's how processes are developed. So there will be errors, but there is something called as accuracy and precision that is available. Right? What do you mean by accuracy? Accuracy. You can tell me, I don't need the book. I don't need the book definition. Your own words, your understanding of what is accuracy. Accurate closer to the true value. We use a technical term called as true value. What do we mean by true value? So there are two kinds of true values. One is, for example, if I have a stereo, okay. So I went to a shop and asked him. First thing I asked him is, I told show me a 65-inch TV. The 65-inch, the one that is inside is 55-inch. Okay. When I asked him the 65-inch, which side do you think is measured as 65-inch in the first place? So this is 65, right? So the horizontal is 65. Correct? That's wrong. It is actually the diagonal. So generally, when you go to when you buy a TV or a laptop or whatever it is, right? When they say the measurement of the screen size, okay, they actually measure the diagonal. So when this diagonal was measured, now what I would do as an end user, I thought is okay. But if I have to be more smart, what am I supposed to do? I should have a tape in my hand, measure and see whether he's telling me the truth or not. You are paying some amount, no 60 pence and 50 pence are not of the same cost. The amount is going out of your pocket, so you need to be careful, right? When you do that, then what can happen? The value which I am able to measure, sometimes there will be actually it cannot be 65 or something, it will be 64 point something will come actually, but they round it off to 65 inch. Okay. So that value, according to the manufacturer of this particular TV, is what is called as true value. Right? I measured something, right? Do you think my measurement is also accurate? I would have taken a tape and measured from that end to this end. There would have been some human errors that would have definitely made. What is it? One is this at a particular height where I'm not able to see. The tape goes here. I'll not be exactly see. I need to get like this and see what is exactly the opposite. I need to look at something straight. But if I'm seeing from here, there is a possibility that due to the angle, there is a small error that is happening. taller than me can tell me an accurate reading for this. So that I can consider it as more accurate because this reading is having zero parallax error is what I assume. You know what is parallax error? When you see something exactly straight. Right? When you take a measurement also, what do you suggest when you go for geometry and try to draw a line segment for 5 centimeter, you don't casually sit and do it. You'll be cautious, you'll mark 2 points, you'll try to take your head exactly top to the scale, and then you'll draw it. Why do you do all those things? Even without your knowledge, why are you doing it? To achieve that accuracy. Right? So accuracy has something to do with the way you do the experiment. So then what is precision? It's not average. Precision is how precise your value is. In the sense, I told you this will not exactly be 65 inch. Suppose I have a tape which is telling me 64.9 inch, and I have another tape which is telling me 64.95 inch. Which reading is more precise? Why is it so? Because I know up to 2 decimal values. So precision has something to do with the measuring device, whereas accuracy has something to do with the person who is actually performing the experiment. Okay. So in both the cases, the unavoidable thing, as I told you already, is. And what did we learn? We try to understand how to calculate errors and what are the possible errors that you have done. For that, I need to know something called as a true value. That is what we are trying to debate on. Right. So for this one, the manufacturer has given me a true value, but not every time I'll have a true value in my hand. So going forward, I know what I want. The main objective of me teaching all these things is I want you to start looking at things around you in terms of physics. You'll enjoy it. Actually. Did anyone tell you that 11th physics is tough? First I told you. Are you feeling it? I want to find it. Is anyone feeling 11th physics is so tough? Sir? My life was using 10th standard. So far not. Differentiation, integration, everything. I thought they're like a piece of cake. You're feeling it, no? Already the feeling has started, no? But it's not actually. You know what is the problem is a lot of mathematics gets involved. And secondly, you have comparatively more portions. Like 10th standard, your life was so easy. You made it 5 chapters, out of which 2 chapters had problems, 3 chapters theory, you escape. But this year, everywhere you need math. That is why in some places they start with basic mathematics. You know, wherever you see, right, if you start asking questions of why you're doing this, you will get so many answers and you start enjoying physics. For example, right, 11th standard is mostly concerned about mechanics. I know I'm slightly deviating out of topic, but those mechanics part is something which is related to the things that you use at your home. How many of you have taken responsibility? Let's say one day the tube light, okay, the LED light starts failing at your home. You're sitting in a hall, you're watching TV comfortably. Okay. For the side and the light in the other, you feel that when you're watching the TV, you have a good experience. Suddenly in the night, the light is gone. How many of you have bothered to go to a shop and buy that light? Have you ever done that? Start doing it. Then when you go to a shop, you'll ask hundreds of questions. You'll say, I need an LED light. He'll ask you, how many watts? How many watts there is it? Is it something like he's a physics graduated, a gold medalist? I think is this an electrician? He knows that this is what is the manufacturing and these are the specifications you need to mention. When you ask the question, you will go blank. After that, question will mind. Till now, I didn't know what I was using for. Upon the sir, if you see the specification on top of it, right, there will be hundreds of things. Lumens have been go to India, but you told you never went to a shop at all. Next time when you do it, right, actually Google or whatever, there is something called as Lumens certificate, LUMENS. 7 fundamental quantities per second. Then what was the last quantity that you used? So for example, when I had to fix this light, right, I had certain issues. Any issues now? Look at the room size, somewhere around 350 square feet. And the color of the wall has something to do with the lighting that I used. So when I had the previous phase, I used Philips brand is Philips. Okay, so I used a bulb which was around 2,100 lumens. Very bright. Then I started seeing that students started problem. When I later, then you will start facing a problem. I don't have a problem here, but you guys will start facing a problem because of it. Then I started again working on it. Then I went down to 1800. That is when I started doing a research of something like this exists. Adla on the 20 watt bulb use for I need to use a 40 watt bulb. So use power consumption will be better for me, which will give me more efficiency. So I started asking all these questions. Syllabus you have it. You have it actually. Last year you learned current electricity, don't say you didn't learn. While a commercial unit of energy kilowatt hour. Okay. Have you ever asked your parents current bill? Have you ever seen the current bill? No, never bothered also how much your parents are paying. It's not your mistake. Too young. They say the amount, no. But how will you know that the EB people are not cheating? There were certain months where the fluctuations went in a 6,000 bill or 12,000 bill. Who is at loss? How will you know? So as a science student, what are you supposed to do? Aren't you the one who's supposed to save your parents? They will not know. Right? So you should go and tell, if I calculate the values and tell, at least let's come to an approximate value of it. That's the actual syllabus. Kilowatt hour that you measured. But have you ever heard that what a layman speaks about in terms of units? Current was right. If at all you see, right, they say 100 units are free. You've heard this at least? 100 units are free. 100 units, this is the slab. For each unit, you need to pay 1 rupee 50. 8 rupees na commercial. For household purpose, it will be somewhat less. It's not that value. But still, you can try to find it on data sheet. They're able to understand what I'm saying. So for a layman, it is 100 units. What are the units? As a science student, what is the unit you're speaking about? Kilowatt hour. Power meter. Meter is a power meter. You'll have a meter on. EB people will take a reading on top of it, right? So on the reading, beside that number, kilowatt hour, which is what you have learned in your syllabus. So why I'm actually deviating and trying to tell you all these things? This chapter, if you're able to master. So if you're able to understand this chapter of why you're doing it, that is when physics will also be the reason. Physics it is also about chemistry also. The reason I'm trying to talk about this chemistry also. I'll tell you why this chapter is important for chemistry. How many of you know cooking? You cook it? So what happens when you put more amount of salt? Let's see, you would have seen YouTube videos and all, right? Why do they say 2 tablespoons of oil? They say 1 onion, okay, 1 onion. But will they exactly tell us what should be the diameter of it, thickness of it? We never ask. 1 onion either. That is why there will be a difference in taste codes. You can ask me, sir, what does food has to do with chemistry? There is a separate branch of chemistry called as food chemistry. Food chemistry is a branch. Okay, that is the basis on which, whenever you go to these kind of, you eat pizzas and all those things, right? They need to have certain combinations mixed. They cannot do just like that, whatever they feed. In the combination mixed, you will get that taste or whatever you call it. So, which cheese is to be used? There are rules. Okay. So, when you start looking at things around you in this format, right? You're able to understand every day. You do it every day. For example, sanitizer. COVID time, you use sanitizers. Why did they say that when you sanitize your hand, don't go near a stove? In alcohol. In what alcohol? It's isopropyl alcohol. I'm not concerned about isopropyl alcohol, but at the back of there is something important that is written which you have learned in your whole chemistry. Stoichiometry, what do you call the basics of stoichiometry? Word you have heard, no? That's the basics of chemistry. In that, have you learned something called as taking measurements of volume by volume, weight by volume? Have you seen? Have you heard this? V by V, W by V. Next time, go to your house, take a sanitizer bottle, read the specifications at the back. It will be written isopropyl alcohol of 95% volume by volume or something like that, which is again a part of insurance. So the volume by volume is actually what is it? It's a machine. Why do we need only to take this much value? Only then that particular chemical will have the required efficiency. Efficiency, right? It will be able to perform to whatever it is supposed to do. So start looking at things in this way and ask questions. Whenever I go to any school, right, this is what I was saying. That is when you will start feeling that 11th and 12th is actually not an interesting thing. Enjoy it. We are relating math also. That's why you learn basic. Either differentiation, either integration, better you know the answer. Why did you learn? Just because your teacher taught you have learned it. Correct? But why do you do this? I have seen hundreds of memes. Instagram saying that, sir, I've learned differentiation in my life, in my 12th standard. Till date, I've never used it. Have you ever seen? Have you ever heard of this? Any of your relatives saying this? When they come to your house, they'll ask you, what I study in my integration differentiation, and they will casually say, right? So when they say that, you should take it as a challenge and ask them, can you tell me where is it useful? Maybe you solve the problem. No idea? No idea. We'll come to that, don't worry. Just making you think. I'm not trying to scare you, I'm just trying to create interest. Okay. You have the real-time applications which are helpful in many things. Like for example, medical industry. When you take this medical industry, there are certain scans that are done. Right? So how are they able to detect that this is a particular tumor that is there at a particular location? Who is actually doing the scanning? It's a human being trying to drill something and open and see inside here. There is something photometric. There are some rays that are going there, and the image is displayed on the screen. But how is the software able to know that this is the place where tumor is present? This is the place where the clot is present. Are the clot or tumor are the Did you ever think of? So it's all about the back end code will be all about your calculus. Calculus is you cannot do it. So that is on a very high level. But if I have to tell you in the language that you understand, integration, you have learned integration. So integration of failure, what is integration? What do you mean by integrating? Reverse of differentiation is a technical term. Integrating is something you join or add something. Last year you learned statistics. Statistics is summation of this. You saw now sigma xi I is equal to 1 to n limits for it. And the sigma is what actually summation. If you replace that sigma with a symbol called elongated s, that is what is integration. Integration of basically you're adding things. And the things add if you're able to get the answer for that, integration is. So you should understand when to use sigma, when to use integral. So when I start teaching you those points, I'll explain. So I spoke about 3 subjects actually, Nagula biology. So when you see everything, right, it is science where the tool to understand science is what is math. This thing is important. So coming back to this point, this is very small. So small, right? There's nothing actually. Right? So we try to calculate different kinds of errors, right? So when we spoke about errors, how did you know that there was an error? If you know that there is an error, you need a reference value, and the reference value is the true value. So how close your measured values to the true value is what we call it as accuracy. Accuracy has something to do with the way we take measurement, and precision has something to do with the device which we are using to measure. So what are the different kinds of errors we discussed? First, we started with what? First, we started with absolute error. Then we had average absolute error. Absolute error. Generally, when you do an experiment, how many times are you supposed to do? Definitely not one time and stop. You have to do it multiple times. The more amount of patience you have, more accurate the values. If you're going to do 5 times, then you'll have a reading. If you're going to do 10 times, more is your accuracy. Then average value will be coming closer to the true value. So what is the absolute error? When you take those readings, you would see how each reading is deviating from the true value. Right. So you take that deviation and add and take the average of it. That's what is called as average absolute error. So absolute error, what do we do? The deviation of individual reading from the true value. Whereas in average, you take the sum of all those things and divide it with it. So on the average, what did we try to find out? We try to understand something called as fractional error. So what is fractional error? It is a ratio of average absolute error to the true value. So average absolute error divided by true value is what is called as fractional. If you multiply the fractional error with 100, you call it as percentage error, right? Then we saw how to calculate the errors for different types of combinations of physical quantities. Z is equal to, there is a physical quantity Z, which is sum of two other physical quantities, A plus B. Or it is a difference of two other physical quantities, which you call it as A minus B. Then what will happen in reality? Each input value will definitely have an error. So A1 is it the exact value? I gave you in the previous class. How did we do the derivation? Measured value of A, how did I tell you? A plus or minus delta A to A. So what does A stand for? True value. Plus or minus delta A stands for the average absolute error. So every measurement will have the average absolute error. If that is the case, then how will the error in Z occur? Try to understand my question. So Z is equal to A plus B or minus B, for example. Then what will be the error, the absolute error that is occurring in Z? It will be the error that has occurred in A plus the error that has occurred in B. So this is applicable for what? It is applicable for both whether you have A plus B or A minus B. Similarly, you have Z is equal to A into B, or you have Z is equal to A divided by B. Then in this case, will you be able to find the absolute error? No, you will only be able to find the fractional error. So the fractional error will be calculated. Delta Z divided by Z is equal to delta A by A plus delta B by B. I think we have solved problems also based on this last class. From the worksheet we did it, no? Similarly, I have Z is equal to A cube or A power M B power N divided by C power P into D power Q, for example, something like this. Then what does delta Z by Z stand for? M times delta A by A plus N times delta B by B plus P times delta C by C plus Q times delta D divided by D. You remember this? So, forgot. We did a problem also based on this. So this is the summary of how you calculate the errors based on combination. For combination errors. Proceed to the next one. Right. So we are done with the first part of this chapter. That is, we saw what are units and how to take the measurements and find the errors occurring in the measurement. Now we are ready to go to the next concept called as dimensions. Shall we start with it? So after explaining about dimensions, then I'll go into a quantity called as significant figures. Significant figures, I'm sure you would have learned in your chemistry also. Okay. So write it down. Write down the heading as dimensions and dimensional formula. So just to recollect the concept, we have something called as 7 fundamental quantities. Like what are the 7 fundamental quantities? Mass, length, time, electric current, thermodynamic temperature, luminous intensity, and the amount of substance. Right. So these are all called these fundamental quantities because they are the building blocks for any other quantity, which we call it as derived quantities. Right. So when you try to express any physical quantity, then this says that it can be expressed in some combination of the 7 fundamental or base quantities. Right. For convenience only, we already have something called as units. Right. So the unit stands for meter, second, kilogram, whatever you call it, right? So these are all the units that you have. So instead of having units, they wanted to understand how many times does a physical quantity depend on mass? How many times does a physical quantity depend on length? So if you want to understand that particular concept, what you can do is, so the advantage of dimensional formula, something called as dimensional formula is, it has nothing to do with what kind of a system of units you're following. You need not break your head about it. Whether you write it in CJ system, whether you write it in SI system, or whether you write it in the combination of both, you can still use this dimensional formula. Okay. So what they have done is, for convenience, the base quantities are generally represented by a letter symbol. And that letter symbol, how they do is, generally if you take mass, okay, mass is denoted by the letter capital L. Length is represented by the letter capital L, the first letter. Okay. Similarly, when you talk about time, it is represented with capital D, not to be confused with temperature. Okay. Similarly, you have electric current, which is represented by the symbol capital E. Okay. Then, if you have the thermodynamic temperature, the amount of substance and luminous intensity, they are represented by the symbol K. Similarly, you have mole and C. Okay. Generally, we don't use them much. So when a physical quantity is expressed with appropriate, it is not approximate, with the exact powers of how many times these quantities are there, then such an expression for physical quantity is called as dimensional formula. So that's what the technical terms say, but let me make it simple for you. If I have velocity, so what is velocity, guys? Is it not meter per second? So small m divided by s. So what you say velocity is, it is dependent on a physical quantity called as displacement. Basically, if you see what is displacement, it is the length. Similarly, if you talk about second, it is time. So what I can do is, if I write the SI unit for V as meter per second, then if I put a square bracket like this, then I read it as dimensional formula of V. So what do I read it as? Dimensional formula of V tells me that meter, it is length. Meter is a physical quantity related to length. So L raised to the power 1 divided by time raised to the power 1. Then this particular mathematical expression is what is called as dimensional formula. Now you read the statement, you will understand things better. So if you have an expression for a, okay, when a physical quantity is expressed, I repeat it, when a physical quantity is expressed with appropriate powers or exponents, powers are also called as exponents, right, of MLTKA, then such an expression for the physical quantity is called as the dimensional formula. Then what are the powers called as? You're writing L power 1, no, that 1 is the power. T power 1 is the 1 is the power. What are those powers called as? They are called as dimensions. What are they called as? Dimensions. So now you are able to understand the difference between dimensional formula and dimensions. So dimensional formula, dimensional formula, you will have the symbol raised to the power of an appropriate number. Whereas dimensions are just numbers. The powers are there, the powers are called as the dimensions of the physical quantity. Am I clear? I hope it's not confusing. So how do you read it? When you put it within a square bracket, right? How do you read it? You read it as dimensional formula of that physical quantity. So here it is velocity. So dimensional formula of velocity and dimensional formula of speed are the same. Right? Because in speed you write distance by time. In velocity you write displacement by time. But distance and displacement both are related to length. Is that right? Shall we proceed? Yeah. So I put it, no, dimensional formula. So it is written here. Dimensional formula for physical quantity is expressed by square brackets along with the symbol of the physical quantity. Okay. So whatever I've written here is again summarized. Observe. For example, the dimensional formula of velocity can be obtained as follows. So we know that velocity is equal to displacement time by time. So whenever you need to write a dimensional formula or you need to write a unit, the first thing that you need to know is the mathematical expression for it. Means you need to know the definition of the physical quantity, or else you cannot write. If I suddenly ask you write down the dimensional formula of torque, you cannot write it because I'm not yet explaining what is torque. You don't know how is torque dependent on other quantities. Whereas if I tell you write down the dimensional formula for acceleration, you will be able to do it. How will you think? First is you will write what is acceleration. Acceleration is what? Velocity by time. Okay, that is the mathematical expression. First, what I will do. Then what I will do, dimensional formula. So I'll put a square bracket and the symbol within it, I'll call it as how is velocity dependent? So what are the physical quantities on which velocity is dependent on? So it depends on length to the power 1 and it depends on the time to the power of minus 1. Except divided by time is dependent on itself once. So what can I write this as? L t minus 2. So this is the dimensional formula of acceleration. Right? So going forward, if I give you any dimension, if I give you any physical quantity, you will be able to think in this form and write it. So to be more specific, right? Generally, what we do is for every dimensional formula, we use M, L, and T. Okay. So since M it is dependent 0 times, I'll write it as M0, L1, and T minus 2. So what is the meaning of this? Acceleration depends on mass. Acceleration does not depend on mass. It depends on length. It depends on length once, and it depends on time twice. Am I clear? Hariharan, am I clear?
Yes, sir.
Oh. Okay. Suppose I give you the task like this. Obtain the dimensional formula of kinetic energy. So obtain the dimensional formula of kinetic energy. Try to write it on your own. Write down the dimensional formula of kinetic energy. So for that you need to know the formula for kinetic energy. What is it? Half mv square. You know this, right? You know the kinetic energy, half mv square. M stands for mass. V stands for so generally constants are there. No, half is there. No, half doesn't have any dimension because it's not a physical quantity. Right. What about mass? Capital L. What about velocity? LP minus 1. So, but how many times is velocity? How many times is kinetic energy dependent on velocity? 2 times. You have square, no? So, how I can write is K is equal to half mv square. This is the first step. Then what can I do? I'll write the dimensional formula of K is equal to the dimensional formula of m into the dimensional formula of v square. Can I write it like this? So, what is the dimensional formula of m? Capital M. What is the dimensional formula of v square? LT minus 1 the whole square. So that gives you ml square t minus 1. That's it. Sorry, half is not needed. Half is not needed. That is one of the drawbacks of dimensional formula. So from this here, from this point, the lesson that you learn is 9th standard you had a chapter called work, energy, and power. Remember? So what is energy basically? The simplest definition from your textbook. The capacity to do work is called as energy. So what did you write the formula for? You wrote for kinetic energy. Similarly, you have potential energy. Right? Similarly, you have work done. Now, if you see, energy and work done are related quantities because whatever work we do will get stored in the form of energy. That is why the definition says capacity to do work. Now, if you see the dimensional formula of energy and work done. When I say energy, kinetic energy, nuclear energy, potential energy, whatever energy you want to talk, has the formula ml square T minus 2. Breathe on. So that's the meaning. Right? So what are the two things that we saw now? We saw what is the dimensional formula, and next thing is we saw what are dimensions. The next point that we are going to see is something called as dimensional analysis. Any doubt? Okay. So the next thing that we're going to see is called as dimensional analysis. Means how are we going to use this dimensional formula for deriving certain quantities or understanding certain things. Okay. So generally, if you see, right, if you want to understand if you want to solve certain problems in physics, then one of the most powerful tools I would say is dimensional analysis. If you have this knowledge, you can solve most of the problems. So that's why it is given. See, the method of obtaining the solutions of several problems, not some several problems in physics by using the formula. Which formula? The dimensional formula is called as dimensional analysis. Okay. Now, the most important point is uses of dimensional analysis. So first thing is, it is used to obtain the relation between units of some physical quantities in two systems of units. So first is, where is it used? So we'll go one by one. I'll just tell you the use, then you can write it. Okay, as of now, listen to this. To obtain the relation between the units of some physical quantity in two different system of units. What is the meaning of it? I have a physical quantity for which I know the units of the physical quantity in two different systems. In the sense, let us take the unit of length itself. So the unit of length in SI system is called as meter. Whereas when you write the same thing in CGS system, you call it as centimeter. Is there a way where you can connect meter and centimeter? Can you? Centi generally means 10 to the minus 2. Right? So 1 meter is equal to 100 centimeter. That's what you're saying. Right? So what did you actually do? You actually try to connect the same physical quantity between two different systems of units. That is what the first point says. Second, to check the dimensional consistency of an equation. So the meaning of dimensional consistency is, for example, I report an answer to you. Okay, let's say I'm going in a car. Okay. Police has caught us for something. Have you ever seen? They'll have a speed or they'll have a meter. If you overspeed below 60 kilometers on a particular route, they'll catch you. Let's say they caught you. Okay. So let's say they caught you for a reason that 60 is the speed limit, but you got caught for 62. That 62 is generally measured in what units? Kilometer per hour, because you went in a car. Okay, suppose I tell you the speed with which you traveled is 62 kilometer per hour square. 62 kilometer per hour square. Will you accept it? What did I tell you? I told speed with which you traveled is 62. Instead of saying kilometer per hour, I told you it is 62 kilometer per hour square. Why? Is it right? The first place. Why is it wrong? Because you know that the unit of speed is always kilometer per hour only. Kilometer per hour square will be for what? It will be for acceleration. So what am I trying to do? Left hand side I told you the physical quantity called as speed, but right hand side I gave you the value for acceleration. So that is what this point is saying. To check the dimensional consistency of an equation connecting different physical quantities means if you have a particular physical quantity on the left hand side, the right hand side units or dimensions should be related only to that physical quantity. You cannot have something else. Okay. This is also another important point which will help you to remember certain equations. Okay. Next is the third one is if at all I tell you that there is a physical quantity dependent on the fundamental quantities these many times, then you will be able to derive the mathematical expression for it. For example, if I give you kinetic energy, I'm saying derive an expression for kinetic energy where I say kinetic energy is dependent on mass these many times and speed these many times. Will you be able to write it? I'm saying derive an expression for kinetic energy where I say kinetic energy is dependent on mass once. So what will you write? You will write m power 1. And it depends on velocity twice. Means you will write v square. So this is the formula, but is it right? So that is the only drawback. But what will happen is you will be able to derive an approximate quantity at least. Okay. You will be able to derive an approximate quantity using this dimensional analysis. Okay. So this is a very, very, very important one. I want everybody to pay attention. So first step is write down this heading. To obtain the relation between the units of physical quantity, to obtain the relation between the units of physical quantity in two different systems of units. To obtain the relation between the units of a physical quantity in two different systems of units. Okay. So here the example that is given is the unit of work. So what is work done basically? Work done, what is the formula? So work done is equal to force into displacement. Right. So the unit of work in MKS system, what is MKS system? meter, kilogram, and second. So in MKS system, what is the SI unit of work? It is joule, right? And that in CGS system is called ERG. Okay. Now the relation between joule and erg can be obtained using the dimensional analysis. How are we going to do that? So I told you work done is equal to force into displacement. What is the dimensional formula of force? Do not know it as of now, but let's try to write. F is equal to M into A. What is mass? So capital M. 1 minute. So which implies dimensional formula of F is equal to dimensional formula of M into dimensional formula of A. So what is the dimensional formula of M? Capital M. Dimensional formula of A? LT minus T. So this is what is the dimensional formula of force. Then what will be the dimensional formula of work done? Dimensional formula of force into dimensional formula of displacement. So dimensional formula of work done is equal to dimensional formula of force into dimensional formula of displacement. So what will I get the value as? I'll get MLT minus 2 into how is displacement measured? L. So what will be the dimensional formula of work done? ML square T minus 2. So there is a mistake here. It is T minus 2. Is it clear? Right. Clear this, right? So we wrote only the dimensional formula, but what is the topic telling you? I need to find the relation between the unit of work done in MKS system and CGS system. Okay. So if I prepare two columns, where the left side column corresponds to MKS system and the right side column corresponds to CGS system. Okay. So in MKS system, you write mass. Mass is measured in terms of kilogram. You take length. Length is measured in terms of meter. Time is measured in terms of second. On a counterpart in CGS system, you have the same mass, but how will you write it as capital M? So mass is measured in terms of gram. But tell me, 1 kilogram is how many grams? That is 10 power 3. So 10 power 3 m in the bracket you write it as gram. Similarly, 1 meter is how many centimeter? 10 power 2 into L, which is measured in centimeter. Second is second only. So 10 power 0 T in the bracket we write it as second. Am I clear till this point? Now, what is the dimensional formula of work done? ML square T minus 2. So for MK system, if I write the dimensional formula on left hand side, I write it as ML square T minus 2. Is it not equal to 10 power 3 times M raised to the power 1 into 10 to the power L raised 10 square into L raised to the power 2 into 10 power 0 into T raised to the power minus 2. So what will I get here? I get 10 power 7 times M L square T minus 2. So on the left hand side, I have ML square T minus 2. On the right hand side, I have 10 power 7 times ML square T minus 2. So left hand side corresponds to MKS. MKS is joule. So 1 joule is equal to 10 to the power 7 erg. That is a meaning. So this is one of the applications of dimensional analysis. I hope I'm clear, right? So please make a note of it. Is it clear, guys? Okay. Can I give you another quantity? Will you try? So I want you to write the relation between unit of force. Right on the heading. Using dimensional analysis. Using dimensional analysis, write the relation between unit of force. Write the relation between unit of force in MKS and CGS system. In MKS and CGS system. For the dimensional formula of force. I think I've already given the dimensional formula of force in the previous problem itself. I've given it here, see. MLT minus 2, mass to acceleration. No? So dimensional formula of force is MLT minus 2. In CGS it is, you know what is right. It's called 10 perfect time. Let's wait for others. So what the answer is? 10 power 5. So you will have 1 Newton is equal to 10 power 5 into something. Any idea what that something is? It's called dyne. D-Y-N-E. In CJ system, force is called as dyne. Okay. Next is there anyone who needs help for that? You could get it. Got it. Again, and you got the answer as 10 power 5 dyne.
Can you repeat that, sir? I didn't hear you properly.
I am saying, did you get the answer for relation between force in SI system and CJ system?
I'm doing. Sir.
Okay. So you will get the answer as 1 Newton is equal to 10 power 5 dyne. Okay. So let me know at the end of the session if you don't get it. Okay. Now you concentrate on the next topic.
Okay, sir.
Okay. So the next, as I told you, it is also used to verify the dimensional consistency of an equation. You also didn't get it. Got it, no? Okay. So it is used to verify the dimensional consistency of an equation connecting different physical quantities. For example, so write down the second application. It is an application of dimensional analysis. What is it done to? It is done to verify the dimensional consistency of an equation. Please write it down. Dimensional consistency of an equation connecting different physical quantities. Sorry, dimensional consistency of an equation connecting different physical quantities. Shall we try? For example, if I have a mathematical equation f is equal to m into v square divided by r, I'm asking you to verify whether this kind of an equation is possible or not. Okay, with the current knowledge that you have. So there is a name for this course. I'll come to that later. So I'm asking you to verify whether this kind of a mathematical equation, which shows a relation between the physical quantities, is possible or not. So with the limited knowledge that you have at this point, what is the technique you can use? Dimensional analysis. So what a dimensional analysis state? The left side physical quantity is there. What is it? Force. So the left side physical quantities dimensional formula should match to the combination of dimensional formula of all the physical quantities on the right hand side. So if it happens, then this equation is dimensionally consistent and it is mathematically possible for you to write it. Okay. Shall we do and see? So if I take LHS, what is the dimensional formula of F? MLT minus 2. By now I hope it is registered. If I take RHS, the dimensional formula of M into dimensional formula of B square divided by the dimensional formula of R. So what is the dimensional formula of M? Capital. What is the dimensional formula of B? LT minus 1 square divided by the dimensional formula of R is L. So you will get M L square T minus 2 divided by L. This L and L will get cancelled. You get MLT minus 2. So LHS is equal to RHS. So this equation is a dimensionally consistent equation. So how do you conclude it? You call it as dimensionally consistent equation. Any doubt in this? Clear? Okay. Now I'll give you another equation. Check out whether this is a dimensionally consistent equation or not. B is equal to A square P, where B is the velocity, A is the acceleration, and T is the time. Is it consistent? Check it again. Is it? Not no. Okay, let me take LHS. Dimensional formula of B is how much? LT minus 1. What about RHS? The dimensional formula of A square into the dimensional formula of T. So dimensional formula of A square is LT minus 2 the whole square into T. This is L square T minus 4 into T. How much will you get? L square T minus 3. You forgot to square. Forget to square, that is right, because acceleration is velocity by time. Did you guys understand what I did? So this equation is dimensionally consistent. Means velocity can never be acceleration square times time. It's always acceleration times time. Okay. So now you understood the second application why we use dimensional analysis to find out whether the given equation is a consistent equation or not. Right? LT minus 1 is for the left hand side. For the right hand side, if I write the dimensional formula of A square, it is LT minus 2. It's a point here. Not here. Acceleration is meter per second square. Okay. So meter is length. Second square is time square. Now it makes sense. Yeah. Right. So shall we move to the third application? And the last application that we need to understand is Hariharan, are you clear?
Yes, sir. Yes.
Okay. So the third application that we need to understand is to obtain the equation of a physical quantity in terms of another physical quantity. Write it down. To obtain the equation of a physical quantity, to obtain the equation for a physical quantity in terms of other physical quantities. To obtain the equation for a physical quantity in terms of other physical quantities. Okay. I'll call it as 20.3. 20th topic according to our book. Okay, 20.3. I'm giving you a question like this. Using dimensional analysis, find the relation between force, mass. Okay. Find 1 minute. Find the expression for force in terms of mass m, velocity v, and radius r. Even before you start, can you tell me what would be the relation? You already know this. You saw this. F is equal to m into v square divided by r. Now what we are going to do is we'll derive it. Okay. So in the previous case, what did we do? They already gave us the formula. We tried to verify whether that kind of formula is possible or not. Now what we are doing, they didn't give us any formula. They told force is dependent on what quantities? Mass, velocity, and radius. Find out how many times it is dependent on individual quantity and write the final mathematical expression for that. How you are supposed to start is, let us say force is dependent. Whenever you say dependent, you write the symbol proportional. Force is dependent on mass, let's say A times. I don't know what that A is. Okay. Similarly, I'm saying force is dependent on velocity, some B times. And force is dependent on radius, some C times. Okay. Then if I combine everything and write, then I can say force is dependent on mass power A, V power B, and R power C. Can I do this? Whenever you remove the proportional symbol, what do you introduce? You introduce a constant. So K times M power A, V power B, R power C, where you need to ensure that this K does not have units or dimensions. Because we don't know what the physical quantity K is. Think. Can you give me an example of a constant which has units? Resistance is one such physical quantity. Similarly, you remember this expression F is equal to Gm1 m2 divided by r square in gravitation. That capital G is called as universal gravitation constant. That also has units. So whenever you are using dimensional analysis, whenever you are trying to derive a physical quantity, you first start with proportional only. But when you introduce a constant, you should always ensure that the constant is a dimensionless constant. Because we don't know what is the nature of it. This is the first rule to be followed. Right? Now, when that is the case, can I say, since, not since, for the equation to be dimensionally consistent. For the equation to be dimensionally consistent, what should happen? The dimensional formula of force should be equal to the dimensional formula of K, dimensional formula of M power A, and dimensional formula of V power B, and the dimensional power of R power C. So what would be the dimensional formula for K? So whenever you say a physical quantity is dimensionless, you take it as 1. The dimensional formula of it as 1. Not k is not equal to 1. The dimensional formula of k is 1. So this I will call it as 1. Now you see. Did you understand what is the difference? I hope you're not confused between the previous one and this one. There we are trying to find out whether it is consistent or not. But here it is we who wrote the expression. So we are saying for dimensional consistency to exist, the dimensional formula of f should be equal to the dimensional formula of all these quantities put together. Is that clear? So what is the dimensional formula of f? MLT minus 2. Do not disturb it. What is the dimensional formula of m? M raised to the power a. Dimensional formula of b? LT minus 1 raised to the power b. And the dimensional formula of r? L raised to the power c. Is that clear? So this I can write it as m power a, L power b plus c and t power minus b. Accepted. See what I did is, if the base is same, powers can be added. So what did you have here? From here you have L power b, and from here you have L power c. L power b into L power c is L power b plus, right? So this is MLT minus 2. So whenever you say the dimensional formula is consistent, whenever an equation is dimensionally consistent, the dimensions are supposed to be same. Dimensions means what? Powers. So when you compare the powers on both the sides, what do I get A as? Very good. What do I get B plus C as? 1. And what do I get minus B as? Minus 2. So from here I got B is equal to 2. If I get B is equal to 2, can I take and substitute it here? So if B is 2 means 2 plus C is 1, which implies C is minus 1. Which implies C is minus 1. And we know that F is equal to K times M power A, B power B, R power C. So what will F be equal to? K into M power A is how much? 1. B power B is how much? And R power C is how much? Minus 1. So you get MB square divided by R, where it is multiplied with the K. K is some constant. So when you are deriving a mathematical expression using dimensional analysis, one of the major drawbacks is you will not have any information about the constant that you produce. When you find it experimentally or mathematically, right, the value of A comes out to be 1. I told you, I'll tell you the name of this course, right? This force is a mathematical expression for something called as centripetal force. You have heard of it? Centripetal force. Kepler's law and all this. So centripetal force means if any object is moving in a circular path, there will always be a force which is acting towards the center. The simplest place where you can see is an atom. In an atom, what do you have? Positive charge at the center, electrons revolve in a circular orbit according to Bohr's theory, and the force that is actually necessary for this kind of circular motion to take place is centripetal force, and this is the mathematical expression for it. Is that clear, guys? So when you talk about centripetal force, the real mathematical expression is F is equal to mv square by r, where k will be equal to 1. So as I told you, in dimensional analysis, there is a drawback where you cannot have information about constant. You can find those constant only by experimental aspect. If that problem was solved, trust me, this one chapter is enough to solve any problem in physics. It doesn't work. Okay. So you want to copy this? Yeah. Please write it. Got it? So everybody is using app, right? You're comfortable, you're able to see the videos and all those things. Should I go up? So if you are clear with this, I hope you wrote down the spot name also, right? Centimeter. PE. Okay, it is not PI. One of the common mistakes in spelling is they write it as PI. It's PETAL. Centimeter basically means center seeking. The schools will always be directed towards the center. Okay. So having this knowledge in mind, now I want you to do this one. Using dimensional analysis, derive an expression for gravitational potential energy, that is U, which depends on mass m, acceleration due to gravity g, and height h. You already know the formula. What is the gravitational potential energy formula? It's mgh, no? But when you derive it, you will not exactly get mgh, you will get something extra. So how we start? The first step is U is directly proportional to m power a. U is directly proportional to g power b. U is directly proportional to h power c. Combine everything and introduce a constant. 100, go through the previous derivation and try to do it. Don't copy step by step, just go through the derivation, understand it, and do this problem. Shall I do? So first step, how should you start with? U is directly proportional to m power a, U is directly proportional to g power b, U is directly proportional to h power c. In most of the books I saw that, I'll tell you what is it. So U is directly proportional to m power a, g power b and h power c. I saw most of you wrote this capital G. Don't do that. Capital G, only one quantity in physics which is already taken. That is a universal gravitational constant. So don't write it. Write it as some k, where you need to clearly mention that k is a dimensionless quantity. Okay? M power a, g power b, and h power c. So for dimensional consistency, what should happen? Dimensional formula of U is equal to. So this time I'm skipping k. You know why? So dimensional formula of m power a to dimensional formula of g power c, sorry, g power b into the dimensional formula of h power c. What is the dimensional formula of U? Energy has the same unit as that of work done. So it is m L square t minus 2. Mass is m power a. Acceleration due to gravity. Acceleration, name itself is telling you. LT minus 2 to the power b. H is length to the power c. So ml square t minus 2 is equal to m power a, L power b plus c, t power minus 2b. So compare on both the sides. A is 1, b plus c is 2, minus 2b is minus 2, upper b is equal to 1. When b is 1 substituted here, c will be 1. So a is 1, b is 1, c is 1. So u is equal to, what did you write? U is equal to k into m, sorry, m power 1, g power 1, h power 1, which is going to be k times mgh. In reality, what the k is? 1, which we will be able to derive it in the proper manner. So using dimensional analysis, you can never find what is the value of k. I hope it is clear. So we are done with 95% of the chapter. Okay. There is only one important thing that is left out, that is significant figures and how to find the significant figures. And secondly, I need to tell you the drawbacks of the dimensional analysis. Where all it will fail. There are some 4 to 5 drawbacks that are there, which we will discuss in the next class, and we'll close it. Tomorrow we'll do problems from some worksheet. Okay. So there is a method of finding the length using parallax method and all those things that I'll explain it later. Because I want you to have some trigonometry knowledge, only then you will understand. So after this, after the completion of this chapter, I'll go to the basics of mathematics. Then I'll start off motion in one dimension. Either through experiment or either through a proper mathematical equation. See, it is very, I'll just tell you something, see if you're able to understand. If an object is dropped from this height, okay, let's say this height is h. Okay, let's say mass of the object is m. You know the difference between mass and weight? So mass is the quantity of that substance, weight is force. So weight is mg. You know this, right? F is equal to ma. So a is replaced with g because g is the acceleration due to gravity. So if I calculate the work done by gravity, what is the formula for work done? Force into displacement. What is force? Mg into displacement is h. So what is this mgh? Actually, energy doesn't have a formula. I repeat it. Energy doesn't have a formula. It only has a definition, capacity to do work. But you're getting that mathematical expression for energy, right? Wherever you see the word energy through science, not only with physics, through science, wherever you see energy, you should always calculate work done only. That work that you do is what is getting converted to energy. That is why the definition is capacity to do work. So whatever work you do is getting converted to energy. For example, you take and drink something, right? it gets stored in the form of some chemical energy in your body due to which you are able to do some work. If I don't give you food for 2 days, what will you do? Right, same logic. Are you able to understand? Now, does it make sense? So using dimensional analysis, you cannot find the K, but this is a proper derivation. So this tells you that the value of K is 1. So this is how you find it. Okay. So the remaining parts we'll see to the next class. Okay, revise it and Hariharan, are you clear?
Sir.
Yeah. Abhinav, are you clear?
Yes, sir.
Okay, then we'll wind up.
Thank you, sir.